Good morning, good afternoon to everyone who has joined us in our webinar today. My name is Zoe Whitley. I'm the Regional Marketing Manager for IDA Technologies based in South Africa. With me today is Elijah Oching, who is our account engineer for civil infrastructure. Elijah is based in Kenya and he will be giving us a presentation today on concrete bridge design, conception to fabrication. Just to give you some tips for the webinar today, we have a Q&A tab that you can use if you have any questions for the presenter. Please use the Q&A tab, and then as we go along in the webinar, we can ask questions can be presented to Elijah, and we can then answer them. If you have any general questions, you're welcome to put that on the Q&A as well. Firstly, I'd like to launch a poll for the beginning of our webinar. We would like to get to know more about our participants today. If you could please participate in the first poll, I'm going to release it now. Thank you. Good. Thank you for participating in our first poll. I'm currently sharing the poll results. So currently we have 88% of our participants are civil or structural engineers. And the role in your organization is road designer or civil engineers, or you're a bridge designer or structural engineers. And then there's, of course, other. With regards to how do you currently model and design your infrastructure projects, some have said 2D drafting and manual calculations, and some have said 3D modeling, computing aided designs, and analysis. Thank you for sharing that with us. I will now hand over to Elijah to start his presentation. Thank you, Elijah. Over to you.
Thank you, Zoe, for taking us through the introduction and the poll. I'll take this chance to welcome you all for having to get time to join us for this webinar. So this is one of the series of the webinars that we've been carrying out on Autodesk InfraWorks, plus some other infrastructure design tools, which are available within the Autodesk Architecture, Engineering and Construction collection, that is the AEC. So today we are just going to focus on Autodesk InfraWorks still. But the previous one, we took you through the basic introduction on Autodesk InfraWorks, where we looked at the model builder and the various functionalities that you can use to do your bridges, roads, and drainage design based on the context of the particular project that you are taking. So the objective of this, as I mentioned, is just to inform you about the various tools and features which are available within the AEC and their functionalities. So today, the focus is on InfraWorks. And as Zoe has mentioned, if you have questions, we welcome as many questions as possible. So there is a chat and questions tab there which you can use to ask as many questions as you want to. And I'll take my time at the end of the webinar to try and address those which I'll be able to answer as of now. So we will not allow for calls because we have a large number of people in attendance. But also you can reach out to us through the email addresses indicated there if you have any further questions, if you are not able to type them on the chat, so that we can answer them at the end of the webinar. So we look at InfraWorks-led infrastructure design tool. And as I mentioned, the focus today is on structural bridge design, where we conceive the project from Autodesk InfraWorks and take it through the various design stages, as you will see. And my topics that I'm going to cover today, we look at the bridge modeling in InfraWorks, so how we model the context of the bridge with the various bridge elements, that is from the pier, the girders, the deck, the abutments, to various design standards that you usually use on your regions for design. Then we'll also look briefly how you can model your parametric shapes, that is using the power of Autodesk Inventor to do modeling of various shapes that are not already available, just to create your custom element shapes from within Inventor, which you can easily import into InfraWorks to update the shapes that you want. Then after that, you look at how you can perform structural analysis. So starting by line guard analysis in Autodesk InfraWorks and sending your model into Autodesk structural bridge design for your detailed design. Then we look at how we can do some freeforms. I'll just do a very brief preview on how you can do freeform rebar detailing in Autodesk Revit, and also how you can easily use Autodesk Revit to do your plan production and documentation. So to do designing bridge in InfraWorks is very, very easy, where you can easily model and create a realistic bridge in the context of that particular project area using the power of Autodesk InfraWorks 360. So it is a part of a cloud computing functionality, which means that the bridge you can perform the analysis of that particular bridge on the cloud. So it also has, you can either decide to use the concrete girders or use the steel plate girders. So you have those two alternatives to choose from, and the concrete can either be a precast or a cast in place, cast in situ concrete. So you can quickly generate 3D concept of the bridge with the related structural elements that you want it to have. So it is an intelligent way of designing the bridge, where you can easily generate detailed 3D model based on a typical design that a bridge engineer would want to use. So as I mentioned, that is the piers, the girders, piles, and even the bearings. It also allows you to use parametric design. So where I was mentioning, you bring the power of Autodesk Inventor into your design, where you use it to generate and model 3D shapes, particularly where the elements that you want to use are not already available within Autodesk InfraWorks. So to edit the bridge is very easy. So just a matter of clicking on it and gripping it, and it can automatically adjust. And the change that you make on one particular element can easily be applied to any other element that has similar characteristics to the one that you are editing. That is, if let's say you want to model a pier, and you'd want to apply that change to any other pier within that particular bridge model, just a matter of selecting and applying, and the shape or the property that you want to have will automatically be applied to the remaining other piers. So you can use the asset card for more detailing and editing of that particular bridge that you have. So it makes the modeling of the bridge quite a dynamic way of having it, and very, very easy. And as you model it, you also now have to start considering things like the clearance envelope check. That is the overall headroom that you're supposed to have, maybe where the bridge crosses over an existing road or railway. So it will do to give you at least to know that maybe if it's a railway crossing or road crossing, what should be the minimum clearance that you should have above that particular existing road. And once you do that, you can also optimize the design of the bridge using the intelligent tool. And as you do the bridge design, you can also start by looking at the quantities that you should have for that particular bridge, just by a matter of selecting, and it will tell you the volume of material required for concrete, required for steel, both for the bridge, in overall, but it can also specify for the superstructure, substructure, and that particular element which you have selected. So you can just select view quantities for a girder, one individual girder, or a quantity for the overall girder that is present on that particular bridge model. So once you are done with the modeling the bridge and ensuring that the shapes and the elements that you have meet the minimum design requirement as per the particular design standard that you're using, you can now perform the line guard analysis. And remember that when you're modeling the bridge, it can also allow you to add loads, that is the imposed loads based on the designs that you have adopted. Then once that is well selected, you can proceed to perform your line guard analysis, where you'll be able to get a detailed structural analysis report of that particular girder that you have selected. And if there's a girder which failed to pass through that analysis, it will also highlight to you based on the design standard that you chose to work with. So we'll also be able to see the different design standards that you can use to perform the line guard analysis and related analysis for that bridge design. And once you have performed it, you can now send your bridge model into Autodesk structural bridge design, which has now more tools and functionalities specifically for structural analysis of the bridge. You can now have more control in terms of the loads that have been applied, more control in terms of the material that are being used to do that particular design of the bridge that you're working on. And you can also use it to generate a very detailed report for each girder and even for the abutments and the piers that you're having within your bridge model. So that's just the short presentation on what I intend to do. So I'll now just switch to show you, to go into InfraWorks so that we can have a look on how we can do a bridge design. So I believe that you can see my screen. So if you can't see my screen, just type in the chat there to let me know that you're not seeing it. So just, if you can't see my InfraWorks screen, just let me know. So I'm having a road which is already proposed for design. And this road crosses an existing railway line plus another smaller road here, this low class road here, which looks just like a footpath. So we intend to do a bridge on this particular road. So as you can see, this is the proposed road that we want to do a bridge. So we want to ensure that this bridge is, the road is well separated from this rail, and also ensure that you are having the right envelope, that is for the headroom check here, and also for this particular road that you are having here. So this usually has always been a problem between a structural engineer and a highways engineer, where agreeing on the exact bridge model to use in terms of maybe how the bridge geometry will align with the road geometry, that is in terms of the center lines, where you find that maybe during the construction, there are usually some discrepancies between the two geometries, especially where the bridge is being constructed by a different contractor from the one which is constructing the road. To start modeling the bridge is very, very easy. So if it is the road that we intend to do a bridge on, we just need to know, based on the survey that has been conducted outside there, where we want the bridge to start and where the bridge will end. So I'll just use some random start and end station for the bridge, but I can just choose, maybe I can choose station 1 plus 675 meters to a particular station of maybe 1 plus 800 meters to the other side. So if this is my intended start of the bridge, I'll just right click. So I first select the road on which I want the bridge to be done. So if I've selected the road, I'll just go down, scroll down after right clicking, and I will see a tool for adding a structure. So there are quite a number of tools that I can add. So like I can add a bridge or a tunnel. So in this case, we're only interested in adding a tunnel. So as you can see, you can also support this road at this point where it crosses the bridge using a tunnel. But let's just for today, let's use a bridge. So I'll add a structural bridge. So the first thing it will ask me is to identify a start of the bridge. So the start of the bridge, I want it to start. I'll just first start by clicking some random values. So I want it to start at station 1 plus 675 as the start. And at the end, I will take it towards this other side, maybe at 1 75 as 1 plus 875, so that it can also totally cross over that road there as well. So I'll just click to that particular end of the bridge as well. So if I've clicked the start and end of the bridge, I'll just give it some few seconds to refresh and synchronize, and it will give me a model of the bridge, as you can see from there, with the proposed girders, abutments, piers, piles, and even the bearings, as you can see on your screen. So that's basically what it has given us. So it also gives us a deck, like right of now I've selected not to show or display the deck, but I'll just select to show me so that I can also have both the deck plus the road on top of it. So it's just a matter of selecting what to display. So I'll select to display both the deck, bridge deck, plus the road that is running on top of it. So that's how easily I can quickly do a model of the bridge based on the context. So the next thing, after having done it randomly as I've just done it, is to now start controlling the exact start and end of the bridge. So my bridge right now starts at station 1 plus 6, 75.105 meters, but I want it to start precisely at a particular station, like let's say I want it to start at 1660. I'll just type 1660 there and enter. So again, it takes a few seconds to synchronize. Then I'll also go to where it ends, to this other side, and also have a precise value for it. So I want my bridge to be 200 meters long. So in that case, I will type this other end to be 1860 as well, because the start was 1660. To have 200 meters long, I will do it at 1860. So the next thing now, after doing that, is to now check which design standard we are using to do this particular bridge. So to check the design standard, it's just a matter of scrolling. And if you scroll down on the right-hand side of the screen, you can see it tells me the attributes. So I can select the attribute is just the design standard and precisely the number of piers that you want to use. So like if your country, they use majorly British standards, that is the BS 5400. You just select, it will automatically update the bridge with the minimum design requirement as per British standard. If you select Eurocode, whether you're using the Eurocode with the UK annexes, if you're using AASHTO, they are all present here, or even the Australian standard that you can also use. So, but in this case, I'll illustrate one using the AASHTO load resistance factor for design. That is the AASHTO LRFD. So, as you can see right now, it also gives me the minimum spacings, that's the spacing between the piers and between the last piers and the abutment. So right now it tells me that the spacings are 35 meters long. So 35 meters, that will require quite a deep section for the girder. So what we may need to do is to now start maybe increasing the number of the piers so that we'll be able to reduce the length of the girders, that is the spacing between the adjacent piers. Or if there are some proposed road furniture along the bridge also, you can just go ahead and add them as well. So I just want to add the guardrails, the lamppost along this particular bridge also, very, very fast, just to ensure that we have a complete bridge before I move further. So I'll just right click, and I want to replace a road assembly. So to ensure that I have the right assembly at the top of the bridge, the one which includes even the lamps, the guardrails, the footpaths on this particular bridge. So I'll just go here and select. So I want to select a bridge. So there are already standard road assemblies for the bridge that you can just select, but you are not limited. You can still go ahead and generate your own. As I mentioned, we can use the powerful tool of Inventor to generate our own sectional assemblies as you'd want. So I'll just select a bridge with 4 lane plus a median with sidewalk. So if I select it, I'll just need to select where it starts. So I want it to start some distance from here. So in this case, I want to start maybe 10 meters from the start of the bridge. So therefore, I make it say 1650. That's at the start. Then I'll go to the end and make it also to end some 10 meters after the end of the bridge. That will be 1870. So I'll just confirm, because I intend my bridge to be 200 meters. So the carriageway with the different road furniture that we require for the bridge should be about 220 meters long. So let me just check on this, and I will drag it to the end where the bridge ends. So the bridge is going and ending on this opposite side. So I will type for it 1870 and I will enter. So if I enter, you can see it tells me that for the length on which I intend to provide the different structures should be 220. So if I enter, it takes some few seconds again to synchronize. And it should now give us all the elements that we require for that particular component of the road where the bridge has been inserted. So I can just zoom into it, have a look. So my road here there's quite a steep slope at this particular area though, but if it's a detailed design, you have to ensure that you have the right elevations at the start and end of the bridge. So that's how we can easily change and include the guardrails, the fences, even if I want to introduce a fence just for safety measures, you can easily do that. So even if I want to now control the length of the footpath that I'm having, the walkways, the width, the depth, the slopes, you can easily do that for that particular bridge. And most important to note is that you can also do the slope of the bridge will be guided by slope of the road in many cases. So like even if it's a road which is having a super elevation, if you apply a super elevation to the road, the bridge will also automatically adjust, take up the slope based on that super elevation that you are having. So like if I want to have a walkway of let's say 2 meters, I just type 2 meters on the width and enter. Then after entering, and it just takes a few seconds to again synchronize the change. Then I can also do the same on this other side. So that's basically how you can model and vary the different components of the bridge that you are now having. So the next thing you can now check maybe on the load that is automatically applied based on the AASHTO that you are having and the class of the road that this bridge is carrying. To check on that, you just go down and select the deck of the bridge. So I want to select the deck, bridge deck. It should be, just go into that position and you can see it tells me this is the deck that I've selected, and it tells me that my deck will be done with a cast in place concrete. It tells me thickness of the deck, the edge thickness. If there is tapered ends of the deck, it also gives me all those parameters. But what is important down here, it tells me strength of the concrete that is used to do that particular deck as well. So it tells me that the concrete is of class 35 Newton per millimeter square. Then the superimposed load based on the AASHTO that I'm using is 3.0 kilonewton per meter square. Then the wearing surface also, it has applied a thickness of 0.05, that's like 50 millimeters. Okay, even if I have hunches on my bridge, I can also automatically check on this. Then the continuity of the bridge also, which is a very, very important, of the deck, is a very, very important factor. It defines how the supports will be applied, whether you want to support the deck on the piers or just going to be one continuous deck. So like in this case, the default one is a deck and girders being continuous, which means that at the point where the deck slab meets with the girder, it is going to be one continuous structure. And that full continuity arrangement just ensures that during the in situ construction of the deck, you will have to apply some diaphragm over the piers when the bridge is now being constructed. So that's basically how you can control what you have on the deck of the bridge. So the next thing which maybe you can look at when generating our model still is now the exact position and spacings of our girder. So like I said, that they are currently spaced at 35, which you are saying that's quite a longer, will result into very large and deep sections of the piers that we use. So what I may need to do, I'll just increase the number of piers to 7, or let me just use 8, so that we can have a value of less than 25 as the number of, as the spacing between them. So if I increase the number of piers again, it automatically synchronizes and takes a few seconds. And when I now check on them, it tells me that the spacing between each of them is 21.87 as opposed to 35. And therefore, that is a good value that you can use, because our sections for the girders won't be that deep now. So the next thing now is we want to control even like the length of the column on the pier. It's just a matter of selecting one of them and working on it. So like maybe where we are here, we do not foresee use of piles, but the default girder here, the default pier here has piles. So what I may need to do, I'll just select on that particular bearing and the pile there, and check on my right-hand tool here. That's the asset card here, where I can manage my assets that I'm having. So what I need to do, I do not want to use piles. So I'll just make the number of piles 0 in each of them. But again, whether to use pile or not is informed by the geotechnical investigation on the project area. So I just want to make everything 0, so that I will not be having piles on my model. Then maybe you'll assume that the hard rock was found some distance below the ground. So you can say maybe it was 2 meters deep below the ground. So therefore, I'll just say that the height above the ground or below the ground for this particular foundation should be, let's say, yes, we found it at 2 meters below the ground. So I'll just type 2 and enter. And if I enter again, it automatically synchronizes and changes. So that automatically means that the height of the column will also increase. Then the next thing is maybe based on the size of the road that we are having, we may find that 3 columns it's likely to have maybe a greater spacing. So like right now, if I check, it tells me that my columns are spaced at 12 meters wide. So what I may need to do, I'll just increase the number of columns. So as opposed to using 2 of them, I can use 3, and I will enter. Then it automatically changes, and you can see I'm now having 3 columns there. So you can go ahead and change each of the elements that you have just one by one until you have the exact project model that you'd want to use based on the design intent. So once I do not need to do it in all these individual elements that I'm having for the piers. So if I want all of them to take the shape of what I've just done with this particular one, I'll just right click and apply to all piers. So if I click apply to all piers, we'll see that all other piers will have 3 columns. We can see they have updated, all my piers are having 3 columns. So the next thing also, since I do not want to use piles, I'll just again right click and apply the pier foundation to all other piers that is in the model. So but that's how easy you can use it to model the bridge. And as you model it, it's being modeled as per the design standard that you had selected. Okay, so you can see right now I only have the piers plus the foundation, no piles. So the last thing maybe to look at is now the girders, which again, the girders are being guided by the design standard that you chose, because each design standard have their own proposed sections and sizes of the girders that you are going to use. So like since I'm using AASHTO, it has automatically selected for me the AASHTO based on the size of the bridge and the spacing of the piers that the sections will be able to accommodate based on the load that's going to be applied on it. And if I select on one girder, it tells me that the material properties for that girder I've selected, the strength, the final strength, that is after 28 days will be 5 to 55. That's the class 55 concrete. The strength at transfer, that's when you're doing pre-stressing, because it is going to be a pretension girder. It will be at 40. Then the tendon strength also is proposed to be at 1860. Then the initial pre-stress is at 75%. So it gives you such details based on the particular design standard that you have selected. So even if I want to increase the number of piers of the girders based on the carriageway width, I can increase them so that I will not overload each of them. So the only thing I need to do is just maybe I want to use 7. I want to use 8 for this. I'll just click and enter. And it increases the number of them to 8. So the next thing is now to decide on which exact girder I want to use. And again, this is greatly the choice of this type of the girder to pier to use is informed by the spacing, where if they're closely spaced, you can use a lower class or a lower type of a girder. So like in this case, for usually between a spacing of 20 to 30, it's recommended that you can use for AASHTO, you can use type 4 or between type 4 to type 6. So as you can see, the types are all available there. So like right now, I've only filtered for it to show me the piers as per AASHTO. But there are quite a number of them. Like if I just remove there, you can see it populates itself, and it has quite a library of different design standard girders that you can have. Even if you want to use box girder, they're all present there, just a matter of selecting. So if I'm only interested in using the one for AASHTO, I'll just type AASHTO there, and it filters to display to me only the one which are for AASHTO. So like I said, in this case, we are having a depth, spacing between the piers of 20 to 30. So I'll just go for type 6. And if I select type 6, it automatically selects. So if I want to have this property I've selected for these girders to apply to any other girder within the model, I just select and apply to all other girder groups within the model. So that's how easily you model the bridge. And as you model it as per the design standard that you are using. So they're using the AASHTO, the British standard, and what have you. So right now, that's our bridge, that's what we have. So the next thing, maybe if you are wondering how I can now control the exact location of each of the position for my pier, is just a matter of clicking on one pier. And as you click, it can give you a way of controlling the offset. So you can see that right now, the spacing between them is 21.867. So I just identify the start. So it is starting from this abutment. So if I select this one here, I can have a control on the exact distance that you will be having. That is center to center of the abutment and the first pier. So like if I want it to be 24 meters, I'll just type 24 and I enter, and it will readjust itself. So even if it is a skewed bridge, you just need to select the angle to which it is skewed and change the orientation. So the same thing which I've done with the piers, girders, the foundation, is also applicable to the abutment. So I just need to check on that particular abutment that I'm having here. I'll select it. So I need to go below the ground because my abutment, this is it. So if I select the bridge, then I select the abutment, it tells me again I can choose from different library of abutments that are already present. So you can even choose an abutment with the cups plus the piles, or just the simple abutment or abutment plus wings. So in this case, I'm using the abutment plus wings. So to change the size and the parameter that you want to have in terms of the which concrete to use, whether it's going to be a precast, cast in place, or steel, just a matter of selecting from what's already present on your asset card on the right. So like I want it to have a depth of, let's say, 6 meters based on the height of my next adjacent pier. I'll type 6, both right, left, and center, and I will enter. So if I enter, it automatically adjusts itself. And now you can see it is going down almost the same height with the piers that I'm having next to it. So I'll just apply that to the next abutment. Okay. So that is it with the modeling of the bridge. So you can see the modeling of the bridge is very, very easy. And as opposed to just modeling from scratch without the required sectional properties and the material that you want to use, it will like take you forever to do that if you were to start maybe doing it manually. So like in this case, we model it by just a matter of picking from different elements that you'd want to use. So I was mentioning that in a case where you do not have you may find that you want to use some specific sectional sizes, pier sizes, and type, which may not be present in Autodesk InfraWorks. What you need to do is you just open your Autodesk inventor. So I will just illustrate to you shortly and quickly how you can create your own custom shapes using Autodesk Inventor. So I will run Inventor and share my screen for a second. So I want to illustrate to you how you can easily. So let me share Autodesk Inventor. I've just run it. So let us assume maybe you want to do a particular shape. So I will just illustrate to you with the one that I was already working on. So like, let me just open it. So you confirm to me that you can see my Autodesk Inventor screen. So I'm just running up a sketch I was making for my required pier. So as opposed to using the rounded pier columns, I can just go and sketch this kind of, let me just open it, just taking some few seconds. So if I click to open, I want to just open the one which I'm already having there to illustrate with. So this is the one that I had created. So to create this is to create a similar one with this is very, very easy. I just start from the sketch. So I'll just double click it. Just a minute. So I want to go to each sketch. Just a minute, 3D model. So I want to illustrate using, or maybe let me just show how to create a new sketch. So I want to create a new sketch. So what I will do, I will go to the origin and select the plane to which I want to work on. So then I will switch the view by just changing the orientation on which it is. Unfortunately, what I want to show is not picking up. Maybe let me just start a new one so I'll be able to show you what I intend to show you. So I want to start a new one by creating a new parametric shape. So once I've gone to new, I'll just select the origin on which I want to work on. And I want to use that origin to do a new sketch. So to do a new sketch is very, very easy. So I just want to, I want to start by doing a line from here. Maybe you want to do for 4,000. So I want to create a typical pier as opposed to what I'm having in InfraWorks. So I want to create a parametric shape here for a typical pier that one would want to create from custom section. So I just want to do it from 4 meters from the center. Then maybe you want it to form the shape of just one continuous pier with a widening top so that it will automatically support the girders on it. So maybe at this particular, I want it to slope at, let's say 75 degrees. So I will not go precise, maybe approximately 75 degrees. And I want it to have a height of 9,000 or 9 meters. Sorry. Let me go back to the screen. XZ, please. Okay. Okay, that does not work for me. So sometimes using this inventor is mainly for mechanical models. So trying to use it sometimes may bring you issues. But basically what I wanted to do, I wanted to show how we can create a shape like this. So as opposed to using the circular and the individual columns that we apply through the foundation, we can use it to create this kind of model, which we just export into Autodesk InfraWorks. And as if you export into InfraWorks, it will come with the shapes, and it will be parametric in that if you change the height, it automatically adapts and take the height that you are trying to change, the length, the dimension, any dimension that you come with from here, just by a matter of sending it. When you click finish, you can send it and go back into InfraWorks to access and import it among the different elements that you have. So that was just to illustrate that you can, as opposed to just using the default shapes and the parameters that you have, you can go ahead and define your own. So that's why you link up Autodesk InfraWorks plus the Autodesk Inventor. So Inventor just for modeling and creating different shapes that you would want to have. Okay, so I'll just go back again to share a new screen that is InfraWorks. So we can continue with it. So I'll just assume that as of now, our shapes are okay and they meet all our design requirements. So the next thing is to now perform some basic line guard analysis and be able to send our bridge into structural bridge analysis and design. So to perform that, or even before you perform that, you may get some overheads in terms of the quantities that you're going to have. So like if I select my bridge here, you can see the tool here for bridge among the tools that I'm having here. I can quickly generate quantities just by a matter of clicking it. And if I click, it will tell me the quantity required for the structure, superstructure, substructure. And if I've selected a particular element, like if I have selected this girder here, it will tell me that the selected material element or girder requires a cast-in-place concrete, no precast concrete of 121.20 meters cubed. But the overall superstructure requires this particular amount of concrete for the precast and the cast in place. The same also with the superstructure. And as you can see, our superstructures were all cast in place, so we do not have any under cast in place concrete. Then still, we do not have any steel element in this particular bridge, and therefore that's why it tells you it is 0. So that's just basically to know at least the expected quantities that will be required to do this particular bridge that you are having. So once that is there, you have reviewed the quantities. The next thing you may consider is now to perform a line guard analysis. And a line guard analysis is now the structural analysis of the bridge based on the loading and type of the road on which the bridge is being done, and to the specific design standard that you have selected. So it is a cloud computing functionality, which means that you will not even require the processing power of your computer. It's just a matter of loading and selecting the bridge, and it will go online to the cloud, take some few seconds, and perform the analysis using the structural bridge design tools. And once it has done the analysis, you can download and get the data back into your software for further viewing. And if there are any design changes that you may need to make, you automatically send the bridge into structural bridge design, which is specifically meant for structural bridge design and analysis. So since it takes some few seconds, you can see that I can define on my permissible factor. So like that, since I'm using the ASHTO LRFD, I need to define my permissible factor. I need also to define where I'm going to plot my bending, whether it's going to be the reverse or just the normal one, and also whether my tendons are going to be hacked. So once I've ensured that everything is okay here, I can even also check on my project information just to ensure that the project name, these are what are going to be printed on the report that's going to be generated. So like the name of the designer, the name of the project, the logo, address, company name, whatever, and name of the project. So those are what you define as the project information. And once everything is defined as okay, you just click start. It will go online, take some few minutes, and you can generate the result here. So since it takes about between 10 to 20 minutes to get back the result to you, I'm not going to do it, but I'm just going to load the one which I've already performed analysis on so that you can have a look at it. So I will just, so remember in our previous webinar, we showed you how you can create different proposals. So like this bridge which I have not analyzed is in a separate proposal from the one I've analyzed, but they are exactly the same bridges. So I'll just go back into a different proposal by switching my proposals tab into the one which I'm having the analysis and the report already done. So that's what I'm switching to. So it is exactly the same bridge. So this is the one I was working on previously, which I have the result analysis results already downloaded to minimize time. So if I select it, I can just go into my line guard analysis, and you can see it tells me the analysis is complete. And the girders which were analyzed are 49, and the girders which satisfy design requirements are also 49. So that means that all the girders that I analyzed meet the minimum design requirement. Okay, so maybe I can just have a look of, I will want to turn off the bridge deck and the road on the bridge so that you can look at the girders only. That's what I've just done. So if I select right now, just a minute, let me select the bridge again. So you see right now, if I select the bridge, these are my girders, that's how they are spaced. So I've just turned off the display of the bridge deck plus the road on it and other road furniture on it. So I'm only looking at the structural elements, that's the piers and the girders plus the abutment. So you can see right now, these are the girders. So the girders which do not meet the minimum design requirement based on the design style that you've chosen will be in red. The one which were very, very satisfactory, which satisfactorily met the design requirement will be in green, which means that they were very, very far from failing. They will be in green. And the ones which were just about to fail but did not fail because they met the design requirement will be in this particular color you are seeing here. Is this color? I think this, I can't say this color. I'm not good with colors. But I know it is a color displaying that they're just about to, but they did not. So if I want to view individual result for individual girder, I'll just select one girder, and you can see it tells me the different load tests through which it was subjected. So like the live bending moment, that is service 1 and 3, in the positive axis, this here was the load resistant factor. So it was 0.69 plus 0.69. So remember that we always work so that the ratio should be less than or equal to 1. So as the values approaches 1, it highlights to you to tell you that it could have some issues on the actual, when it's now performing its service. So you can see that the pre-stress transfer, if you perform analysis for the pre-stress transfer, erection stage, the live bending strength 1, live bending service 1 against 3, you can see that the shear, the construction stage, because those gives you the sequence through which the bridge should be constructed. So it means that if you're performing construction stage, if maybe it is partially loaded, how will it be affected in terms of the loading? So you can see that the ratio is very, very low. Okay. So basically that's how you can get the report, and you can see that it tells me I can get full report. So full report will be a detailed structural analysis report for that particular girder. So where we'll be able to see how the calculations were performed to arrive at these particular ratios that is shown to us right now here. So if I want to access the full report, I'll just click get full report, and it will open it in a PDF report. So I will just switch to share my PDF viewer on which the report has been opened. So just give me again some few seconds. It will take some 1, 2, 3 seconds to open up. Make it full screen. And then that is it. So let me share that PDF. It is this one. So you'll see how detailed a structural design report it gives you for the girders. So you can see just start by giving me the company name, the job, concrete bridge design, dates, the calculations by, checked by, project name, data file. Okay, so you can see it gives me even a table of content of what is in that particular report there. So like it tells me the content is for girder design summary, girder design calculations, the transverse live load distribution factor calculations, the analysis load envelopes, the analytical model data. So you can see it is very, very detailed, like in the girder design summary, it gives you now the different structural element, that is the reinforcement on the deck, the tendons required for the pre-stressing at the girder. It gives you plus in their exact locations within that particular girder that you have selected. The moment diagrams, the shear force diagrams, the permissible moment, the design moment, permissible moment, negative, positive. So it gives you quite a very, very detailed report that you can see and even use for the approval purposes if there is need. So we can discuss this at length, maybe in another webinar where we just focus on how this particular report is generated, but I promise you it will be very, very hectic if you have never designed a bridge. So it's a very, very detailed and step-by-step calculations, which was showing us the ratios that you are using to show that the bridge passed the analysis. So it now is illustrated to us in this report how they were calculated with the specific clauses from the AASHTO that was used to perform those calculations. So like, and you can see here, for the permissible stress in the precast beam, for compression, it tells us the article from which that calculation was derived. That is article 5.9.4.11. The permissible compression stress is given by 0.65%, 0.65 times the strength of the concrete. It gives you even any detail that you require. So those who have been doing the design of the bridge, I'm very sure you are aware, you are all conversant with that. But if you now want to vary those design results, I said it's just a matter of clicking and sending this bridge into Autodesk Structural Bridge Design. So I will just share another screen to show you how we can easily send that bridge into Autodesk Structural Bridge Design. So it's still on InfraWorks. So we have seen at the report, but if you want to make changes and review the report in details and even generate customized results, you send your model by opening it in Autodesk Structural Bridge Design. So I'll just click Open in Structural Bridge Design, and the interoperability is quite very fast. So if you just click, it directly links you to that particular software you want to view the element that you're talking about. So I'll just click. As I've clicked, it takes a few seconds to open. So it opens the bridge itself with all the girders, the piers, the abutment that we have. In first it will show it to you in analytical model. So structural engineers are very conversant with this. This is the analytical model of that particular bridge we were seeing. So when you're talking about structural design, these are the models that you talk about, not the one we were seeing in InfraWorks. So that just tells you the level of detail that you can have when you are having the structural bridge design. And of course, the first thing we do, okay, I think my screen stopped, so let me just share it. Okay, so this is my bridge model, the analytical model in Autodesk Structural Bridge Design. So you can see it's also a very, very simple software, but very, very detailed in terms of designing bridges. So I'll just, maybe we'll take one of the next webinars, maybe we'll just go through it. So you can see here, it also has the different design standards and the codes that you can use, from British Standard, Australian, AASHTO, Eurocode, and even the Eurocode for the specific annexes that are common. That's the French, UK, Swedish, and Irish. But I will not look into those. So what is important when you now do that kind of workflow where you directly link up the bridge in InfraWorks with the structural bridge design, you can now have more control in terms of going precise with the loads, because in that case we're using the default loads which were automatically extracted from the design standard. But with you as an engineer, you may have to use your judgment to now start varying them to know based on the actual execution of the project. So and therefore that means that you can now start viewing things like the loads, the material that were used. So like it tells us that the material which were used for this particular bridge, for the cast in place class 35 concrete, it gives us the exact and the precise material properties. There's the maximum aggregate size that will be used, the correction factors, the coefficient for thermal expansion, the modulus of rupture, the Poisson's ratio, the shear modulus, and all what have you, which we can just take like forever talking about if I were to go into them in details. And you can see also it plots for us the shear stress diagrams to just illustrate to us how the strength was varying, which one was used. Were we using the elasticity or the plastic limits? So that's basically what it shows us there. Like, of course, for concrete, we only use the elastic limit. It's not plastic. So then that's how you can look at each and every element material which were used in this particular. So even if it is for the steel that were used, you can view the properties there. Even for the tendons which were used, you can see, tells you each of them, the reinforcing steel, the tendons that are present there. So the next thing after that, you can now start looking at the loads. So like you can just select one particular beam which was present there. So it gives me the sections, the construction stages, which elements will be constructed first after having done the girder. How should you now approach the construction of the deck? from which side in terms of the support, because we know that when you construct the deck on the load, it applies a construction load, which will obviously cause some problems. And therefore, you have to know how those loads will be transmitted to the piers during the construction. So I'll just look at one of the loadings and how we can also maybe control and remove excess tendons where more were provided. So I'll just go and apply analysis on it. And you can see it gives me this detailed sectional view. So where I can see how the particular deck will be done based on this particular girder that I've selected. So like if I select here, I can now see the tendons by sliding it across the girder, such that if I'm towards this end, you can see towards this end on the top of the deck, there is no reinforcement. So we know, of course, towards the center, we know if you're going to be under compression, we only provide reinforcement at the top when it's up at the support of the beam, at the support of the girder. So I can just slide it back to where it was, so we can see the reinforcement, and it gives us the details, the sizes, the diameter of the tendons which were used. So even if there are tendons that you want to remove, if they are excess, after having varied the loads that you have based on your judgment as an engineer, you can now get those details in depth from Autodesk structural bridge design. So you can add or remove tendons from here for that pre-stressed girder that we are having here. So that's just going into details for each of them. So maybe that will be form one of our webinars where we just focus specifically on how to now change the parameters from the analysis that you have got from Autodesk InfraWorks. So I'll just click OK to close that without changing anything again. So if you maybe want to even optimize on the tendons, we just want to do optimization without changing anything so that we'll use the optimum design. It's just a matter of clicking, it performs the analysis on itself. And if there is what you may want to vary for that optimization in terms of the proximity to the end and the bottom of the girder, we just click and select there. We want to apply debonding, harping, or just straight. So like in this case, remember we are using harping of 75%. That's what it automatically takes from here. So then we can go and check even on the design layout from the sectional view of it here, where it applies the tendons one by one, each at the precise location where they were being done. So in that case, that's what optimization is meaning here. So it will optimize and give us the most optimum design and distribution of the tendons on that particular girder that we have in conjunction with the deck that is going to support. So I'll just click OK, maybe just to end it there. So even if I want to access the individual result for that particular, if I'm trying to abort it, it's not finished. So since I've already started running the optimization, I may just give it some few seconds to finish. But let me just abort it because it will take time, and click OK. So if I want to access the result for that specific girder as per the load that I've selected, remember I selected the transient load for beam 2. So I'll just click result. And I don't know if you can see the result. So if maybe in case you cannot see, let me just go and select it. So this is the result that it generates. Assume you can see my result viewer for beam analysis. So this is the result that it compiled into one PDF and sent to us. In this case, where after having run optimization, I may still have to maybe make some changes on it. Okay, and it gives me these detailed results. I can either have it as in form of Word or in form of PDF just by clicking here, and you'll create a PDF result from it. So you can see if it is PDF, you can even now add your company logo and all those. So basically that's the kind of result we downloaded from InfraWorks directly. So basically that's the detailed design. If you're talking about now the detailed design, so I'll just stop that screen, go back into InfraWorks so that we can finalize. So back in InfraWorks, we assume now our bridge is at the final design stages. You have changed everything in a structural bridge design. So the next thing is where you now send the bridge into Revit for the final stages, that is doing the reinforcement as per the design you have got in the structural bridge design, so that you can do the documentations and the plan a production. So to do that, it's just a matter of selecting the bridge. If you select it, right click, And again, there is an option of sending it into Revit. So to send it in Revit, you have three options. So where you start a new project, so you can see there is an option for creating a new project. And then there is also an option of opening a Revit model. So it means if there is an existing bridge you have been doing, and we have just made some changes on it, I don't have to create a new project every time because they are automatically linked up. So if, like in this case, this is one I've already worked on, so it's just a matter of clicking to open it in Revit, or if it's a new project, I just click to create new. But if I do not want to open it in Revit, I'll just click to update. So which means that it will automatically update the design changes we have made without you having to do them manually. Okay, so like I've already opened it up in Revit, so I'll just share my Revit screen so that we can have a look at it. Revit should be somewhere here. So let me share a new screen. Show all windows, Autodesk Revit. So I hope you can now see my screen. So here's the same bridge. We're now brought up into Revit. So I can go into its 3D view. To go home. So this is the same bridge. It automatically brings it up plus all the structural elements that you are having. So the main aim of bringing it up in Revit is just to now do reinforcement and start doing your documentations. Okay, and the reinforcement you do here are also being done in 3D. So to do reinforcement without having changed anything, I'll just illustrate briefly how you can do reinforcement because of time. So just select on one particular element you want to do. And as you select it, you can see there is a rebar here. But remember, the rebar you will be doing here will be guided by the design results that you have customized from a structural bridge design, as you had seen, where you are sending the model from Revit, from InfraWorks to start with the bridge design for detailed analysis. So if I click on that, I do not want to save it. So the first thing it will do, it will give me the different alternatives of modeling the rebar. So there is what we call the freeform rebar. I can sketch rebar or place it as per the faces that I'm having. And also, they're also important to note that you can see that based on the design standard you choose, like in this case, since I was using ASHTO, it has automatically selected the rebar design as per ASHTO. So that is, it is usually the ASTM. So you can see there, it tells me that the material for the rebar is ASTM, and that therefore it defines the diameter of the rebars, the strength of the grade of the steel that is used to do those rebar there. So since I was using ASHTO, it automatically selects an equivalent of that in terms of the rebar detailing. But if I used BS or Eurocode, it would have given me an option of using BS 8666. Okay, so that's basically how you look at it. So you can see that from this particular design standard I've chosen for rebar, these are the various reinforcement diameters that I can have, starting from diameter 10, 13, 16. So if it was a BS, we could have seen starting from 6, going to 8, 10, 12, 16, 20, up to 30, going through up to 50 something. So they are all present there. And also it is important to note that they are usually up to some shapes. So the shapes, I think I'll be able to control the shape once I've placed one rebar. So I just want to maybe select briefly to place some rebar here. So I'll just select on the faces on which I want to place this. Okay, let me just use this foundation here. So I'll select the foundation plus this, plus this. So I'm selecting the faces on which I want the rebar to be placed. So that's using the freeform rebar modeling. So there's quite a number of alternative ways of doing the rebar. So I want to spin it so I can look at the other side of it, because I want to apply it automatically to the remaining face. So I'll select this face as well. And select that at the end there. Then the bottom face also. So that's the freeform sketching. So the sketch, I'm just placing the sketches of the reinforcement first, then I can edit them later. So then I'll select the direction through which I want them to run. So I want the rebar to run in that direction and click enter. Then I can finish. So if I click finish, I don't know why it is not placing them. It's asking me to repeat that. because I didn't select something right. So let me select this again. I can select that end there. That's the bottom one. Enter. Then I can define the path of the reinforcement. I want it to run through the bottom line, going that way. Then I can click finish. Okay, ideally it's not working for me there, but you can see in this one here, I've automatically done the reinforcement there. And when I do it, it tells me the spacing of the reinforcement, the number, just using the freeform sketching of the same. So see, that can take me time because I have to also customize and know even the exact shapes and codes that I'm using for that particular rebar. But it's just a matter of selecting and clicking on that particular one and doing them in 3D. And as you do them in 3D, you can automatically do the bending schedules just by a matter of going to the bending schedule to create the bending schedule there. But that can take time. So you can see I was placing some random one also on this particular pier, the column head, and it tells me again the spacing to which they were done, the number. And if I want to define them further, I can choose the type of the reinforcement to use, plus even whether to have things like hooks at the end. Okay, basically now you're supposed to be guided by the design that you have got from the structural bridge design in detail. So to do this, the plans, that's just briefly basically how you can easily do reinforcement. To do the plans, you can cut the sections and have the sectional view. So this was the one I was trying to place the reinforcement on from a sectional view I've cut. So you cut the sectional views. You can have as many sectional views as many as you want. And like this as a typical call out for the girder. So if I want to draft it to provide the details for the girder in terms of the dimensions, I'll just select to dimension it. So it's very, very easy. Dimensioning in Revit, very, very easy. So I can just select and dimension that by the faces that I'm having. And just by doing it very, very fast as opposed to when you want to do the drafting in AutoCAD, which is usually very, very manual. So I'll just select that and provide the details based on the material that I'm having or the elements that I'm having. So I want to do that to show the edge distance from that overlap there. So basically that's what you do now to provide the reinforcement and the details that you may want to have. So I have several sectional views that I've cut with the one showing the reinforcement I was placing. But of course, for a detailed project where you're doing the project in detail, you need now to provide for each of the specific elements that you are having on that particular model. So those are the various views that I'd made earlier. And if I now want to produce the plans, I'll just a matter of selecting the plan that I'm having, and I will drag and drop the different elements that I'm having into it. So like the callouts that I've made, I can drag and drop into them. So let me open the sheet. This one already I was already playing about with. So again, so this could now be the work of the draftsman. So you engineer, as an engineer, just your work will maybe end at the structural bridge design. So cutting the section and providing the details here is what the draftsman will now be doing, or the CAD detailer, just now by cutting the different section views, populating them on the right sheet as per your company templates that you can easily generate from here. So basically that's what I intended to show today. Because of time, I will not be able to go in details because I'm already past the time that was intended for this particular webinar. So at this point, I'll just stop at that so that we can take questions. So you can take some 1, 2, or 3 questions.
Yes, Elijah. We've got one question from engineer Abubakar Lawal. She's from Nigeria. Her question is that InfraWorks only have girder bridge options. What about other options like span bridge, slab on deck bridge, cable stayed bridge, etc.?
Okay, that is what is available as the default parameters. That's the commonly designed bridges. So if you want to do like cable stayed bridges, you need to, like if you saw me trying to model some parametric shapes in Inventor, you use Inventor to model them, and now to incorporate the elements in your bridge for design, you import it into InfraWorks. So to do customization is very possible, but now you use either, you can generate them either from Revit, but preferably for infrastructure, it's recommended that you generate them from Inventor. You can do any parametric shape that you'd want to generate.
Okay, we have another question from Engineer Kumu from Kenya. Can you please give us your question? Any other questions, please use the Q&A tab. Thank you.
No question?
Engineer Kumu from Kenya, where do we use our data like geotech and hydrological data?
Okay, geotechnical and hydrological data. For hydrological, you can use in InfraWorks because you can bring the rainfall content and perform even the things like catchment area analysis or watershed analysis and know even the preferred areas where which will be flooded. But detailed one, you do it in Autodesk Civil 3D. The same also with geotechnical. There is an add-on which works on top of Civil 3D called geotechnical design, which you run on Civil 3D, and you can do very, very detailed geotechnical report and analysis based on the boreholes and the report that you got from the site investigation. So you incorporate them from Civil 3D, but not from InfraWorks.
Any other questions? Please put them on the Q&A. Thank you. Thank you, Elijah. There's no other questions so far. Thank you very much for the presentation.
Okay, thank you, Zoe. But maybe just to emphasize, if they have any question, they can still reach out to us through the contacts that I had shared earlier. So I can still show my screen so that anyone who may have a question or maybe would like to get back to us regarding anything on bridge or any other infrastructure that they are currently working on. So those are the contacts. You can reach out to either Zoe or I through those contacts regarding any question that you could be having on bridge design, road design, and even buildings and other projects.
Thank you, Elijah. I'd like to launch the second poll. If you could please give us your feedback on that. Thank you.
Yes, please launch.
Thank you very much for taking part in our call questions. If you would like to inform Elijah and I of any other features that you would like to see in our next webinar, please let us know, or you can give your feedback on the chat. Thank you very much for attending our webinar today. We wish you a further great afternoon. Thank you.
Thank you, Zoe. Thank you everyone for attending, and have yourself a good morning, good afternoon, wherever you are.